example 1. The sketch shows the curve with parametric equation x equals log t plus 2, y equals 1 over t plus 1, t must be greater than minus 2/3. The region R is bounded by the curve, the lines x equals log 2, x equals log 4, and the x-axis. Use calculus to find the exact area of R. So area under a curve. So the first thing we think of with area under a curve is that is the integral of y dx. But because now it's a parametric equation, if we subbed y in, that'd be in terms of t. So we change our variable to be in terms of t, so that is dt dot dt. So y will be substituted in here, dx by dt, so we're going to differentiate this, and we'll sub that in here, and then we will integrate it with respect to t. So the first thing I am going to do is take x equals log t plus 2 and differentiate it, dx by dt. So the differential of a logarithm, differentiate this, which will just become 1 over t plus 2. So substitution, integral, y being substituted in first, 1 over t plus 1, dx by dt being subbed in now, 1 over t plus 2, dot dt. So that is what we need to integrate. Oh, and I have missed off the limits from log 2 to log 4. So integrating from here to here. Now, this might not seem obvious what we're going to do at first here now. So we have a product of two things, but we're not going to use integration by parts because they are the same thing. They're both pieces of algebra. If I were to write it as 1 over t plus 1, t plus 2 dot dt, that might seem a bit more obvious what we're going to do. So this can be split up using partial fractions. So that is what we're going to do. We're going to split this up using partial fractions and then integrate each of them, put in our limits, and then find the exact area. So a little aside, we are going to do first of all the partial fractions. So 1 over t plus 1, t plus 2 will equal something over t plus 1 plus something over t plus 2. So that's what I'm going to concentrate on now, doing this. So timesing through by t plus 1, t plus 2. 1 equals a, t plus 2, plus b, t plus 1. And then I'm going to let t equal negative 1. So then this is 0. 1 equals minus 1 plus 2 is 1 equals a. So that's nice enough. And then t, I'm going to let equal minus 2. 1 equals minus 2 plus 1 is minus 1. So we have minus b. So b equals minus 1. So a is 1, b is minus 1. So going back to what we had before, so I have the integral from log 2 to log 4 of 1 over t plus 1 minus 1 over t plus 2 dot dt. These are both exact logarithms. T plus 1 differentiates to 1, t plus 2 differentiates to 1. So we have square bracket log mod t plus 1 minus log mod t plus 2 from log 2 to log 4. I'm going to do the substitutions I'm going to rearrange first, then do the substitutions. So that is log of t plus 1 over t plus 2, log 4 to log 2. Now, I've been a little careless here in my working. These guys here, and it's easily done. So I'm not going to re-record this. I'm just going to point out my error here. Now, you might have been saying all the way through that I've been making this error. But these log 2s and log 4s, if we go back to the question, they are the limits in terms of x. And so here, they are x's, but we have t's here now. So we want to sub in what they are in terms of t rather than what they are in terms of x. So I need to change both of them. And I probably should have done it at the start. Not probably, I should have done it at the start. But it doesn't matter, I'm going to correct that now. So going back to the question, what was x? X was log of t plus 2. X was log of t plus 2. So these are both x's. So log 4 is equal to log of t plus 2. Raise both sides to the base e. 4 equals t plus 2. T is 2 for that one. And then it's very similar. Log of 2 equals log of t plus 2. 2 equals t plus 2. So then we have t equals 0. And they are what the limits should have been all along. So this one should have been a 2. That one should have been a 0. Makes the substitution, the subbing in a lot nicer now. So we have log of 2 plus 1 is 3 over 4. So 3/4 when we sub that one in. Subbing in 0 now. Log of 1 over 2. Don't want to go on to the next page, so I'm going to come up here now. So now we're going to divide these. So that's log of 3/4 divided by half, log of 3/4 times 2 over 1. They will cancel. Log of 3 over 2 is our final answer there. So just to go back and talk through the error, y dx is how we integrate under a curve. We need to change the limits to be in terms of t, so dx by dt. So we differentiated this to get this subbed in, and at this stage these limits were in terms of x, but because our variable is now t, we should have changed these to t's, which I did later on, okay? But as long as we sub in the right limits, here we go, sub them in there, and then we've got our answer of log of 3 over 2.